Good morning. My name is Irene Quinonero, and I am currently a PhD student in Fine Arts at the University of Sevilla. And my line of research focuses on the influence of optical instrumentation and new technologies in the representation of perceptual limits. And in this case, the project focuses on how nature establishes an order, then creating and generating forms, and how we can represent utopias and fantastic worlds. So we will talk about fractal geometry and computer graphics. We will give a brief introduction of what the fractal structures are and how important the development of computer graphics has been for the use of fractals, not only in art, but also in different aspects and disciplines. And we will talk about three artists, Julius Horthuis, Iris van Herpen, and Michael Hansmeyer, who use different softwares. Well, the objectives of this paper, we will the following. No, first of all, how to know the fundamental characteristics of fractal structures, to observe the applications of computation and the fractal in contemporary artistic practice, and to compare methodologies and tools of different artists through their most outstanding works. So, what is a fractal structure? The term fractal was coined by Benoit Mandelbrot in 1970, referring to all those broken groove and fractal structures. The coast of the islands, for example, the ramifications, geometry that escape from traditional Euclidean geometry. So a fractal structure is any structure that has these characteristics. One is scalable, two self-similar, three it has a fractal dimension that is greater than its topological dimension, and after that is infinite. Well, to begin with, the fractals are scaling and self-similar. The structure can be repeated by reducing its scale or increasing while maintaining its proportions. Hence the principle of self-similarity. As we can see right, we see an image of mountains from the air, but the shape can remind us of the branches of a tree. So the fractal dimension developed by the physicist Felix Hausdorff in 1919 is that which determines the level of roughness of an element. For example, we have a smooth sheet of paper that would be topological dimension 2, and we crumple it. So the fractal dimension makes it possible to determine its roughness, no matter what scale it's on. And at last, we find the characteristic relates of those mentioned above, that fractal structures repeat to infinity. For example, some mathematicians like Julia have investigated fractals and developed shapes such as Sierpinski triangle, which is made up of an equilateral triangle that divides into other equal triangles until infinity. Mathematics and art, as we know, have been hand in hand and have allowed the creation of incredible and determinating works in our culture. In the book Fractal Geometry of Nature by Benoit Mandelbrot, the relationship of the fractal in art is rarely exposed, giving examples such the wave of Hokusai or work of art by Da Vinci. So, in 1998, we find the author Holder van de Boom and Felicidad Romero Tejedor in the book Fractal Art Aesthetics of Localisms, in which they expose the characteristics of a fractal aesthetics that contain properties of fractals that can determine a different way of making works of art. And it's called local construction. They refer to the fact that the final composition is determined by the growth of a certain form that expands through the support, like the growth of nature, like a branch. And however, many architectural works inspired by nature may have been determined by fractal equations to realize the layout of the structure, for example, Sagrada Familia. And in short time later, we also came across the Fractal Art Manifesto, a manifesto that determined the basis of fractal art, among other things, but it's not something that anyone with a computer can do well, and they compare with paint or photography. Anyone can take a brush in their hand and paint. However, not just anyone can be Giorgio O'Keeffe or Pablo Picasso. Well, as you have seen, according to Van der Boom and Tejedor, many works could be determined to have fractal aesthetic, even the plaster work of the Alhambra that inspired Escher. But we are missing something decisive, the infinite. As much as Escher used millimetric pens, the physical limits of paper and time itself limit us from generating infinite structures of a physical support. And that is where competition comes to play. Once again, we will bring back our traveling companion, Benoit Mandelbrot, and we will discuss the role of development of computer graphics in the creation of infinite fractals. Benoit worked in EVM, and one day, interested in fractal structures, he introduced the Julia equation into one of the company's computers, resulting the Julia set. The computer allowed the equation to iterate indefinitely, regenerating the fractal structure. This was a turning point in the understanding of the formation of nature and the application of these equations to many aspects of life. For example, in the detection of cancer, in the prediction of the stock market or topography, and even in visual effects. For example, in Star Wars Episode 3, it was one of the first films to employ fractal geometry, and they used fractal geometry to make more interesting launches and rivers of lava. So if we focus on the field of design and the design and the arts, we can find many fractal parametric programs that allow us to generate structures, animations, and renders. And many of these programs are free, but that doesn't mean that we can be able to generate interesting work using only the software. And we will see this, for example, in the case of Julius Horsthuis with Mandelbrot 3D. So we go to artists and utopias. Julius is a digital artist who used Mandelbrot 3D software to create immersive installations, videos, and images, and more. He creates fantastic and idyllic landscapes, mixing abstract and cinematic animation. As we can see in this work, Julius immersed us realms of light, nature, and technology, using infinity as a hypnosis to retain the viewer in a spectacle of symmetries and a digital baroque that envelops him. Next, from auto culture, we find Iris van Herpen, a fashion designer who is inspired by the forms of nature to generate dresses that elude fantasy, creating a futuristic imaginary where the new technologies work with the organic, generating new possibilities in the design of clothing and accessories. Some of these most outstanding works are made with 3D printing, which allows greater flexibility when it comes to creating and imagining and generating infinite and modular structures from software. As we can see, for example, in this corset, the shapes repeat themselves by increasing and decreasing in size, being self-similar. Finally, and from computational architecture, we find Michael Hansmeyer, an architect and programmer, among other things, who use computational algorithms to generate visually surprising and attractive architectural forms that invite viewers to interact with them. We can see below a 3D model of a design he developed as a scenography for a performance. We can observe the organic lines of its construction that are distributed symmetrically of each side, perfectly organized. And this way of building from computer programs can give an innovative touch to the representation of classical works as it seems to contextualize them in utopian works on the new future. Okay, so as we can see, are just some few examples of how the development of the new technologies can help aesthetics and artistic formulations to appear that allows to dream, to imagine different possibilities in the future. And they can inspire us to create new ways of expressing ourselves and interpreting the world, such as these 3D printer earrings designs made through software that give us the freedom to give form to what concerns us. I have attached a small essential bibliography on which I have mainly based this presentation. And thank you very much for your attention. And I hope it has been for your interest. And muito obrigado.